if A is parallel to B and B is parallel to C, then A and C are parallel. How do you feel about that?
True.
It's not true or false. That is what it is. So you don't have to write any of this stuff. It's not a question. That is the facts I'm trying to get across.
It's given.
That's what it is. I'm asking you if you understand what I just told you. If A and B are parallel, and B and C are parallel, then A and C are parallel. So they're just trying to tell you if A and B are parallel, and C and D are parallel, I'm asking you to, in your mind, justify the relationship between A and C. And they are parallel. That's it. The only caveat here is they can be in different planes. So I wrote it like this. If multiple lines are parallel, they're all parallel to each other. Kind of like a duh one, right? Everything's parallel to everything else and they're all parallel to each other. This one gets a little weirder. This is only true if lines are in the same plane, right? All these lines have to be in the same plane. If A is perpendicular to D, and B is perpendicular to D, then A and B are parallel. Yes?
Yes.
Kind of.
To be perpendicular, that's
Correct.
So they would have to go through the same.
So it's just saying that A and D are parallel, are perpendicular, and B and D are perpendicular. So I'm asking you to come to the conclusion that A and B are parallel. That's what I'm asking you guys to do.
Will they always be parallel?
No. No, I hate God. Thank you for asking that, but I hate you for asking that. Do you know what you just did?
No.
Neither do I. So that's why this part is super important. They have to be in the same place. Can I just leave that linger for a second and come back to it later?
Yeah.
Okay? So the reason this is true, and this is something we went back to last Friday, if these two lines, if these two lines are perpendicular to D, notice how they have two 90-degree angles right here. Well, now those 90-degree angles are congruent, and they're corresponding angles, and when corresponding angles are congruent, it forces lines to be parallel. So it's kind of a revamp of something we've already learned. And you didn't want to hear that, did you? It's too much. So if two lines are perpendicular to the same line, then those lines are parallel to each other. I'm going to revisit. Is it always true? No. But we'll get to it here in a second. The perpendicular transversal theorem. This one's disgusting. If A is parallel to B and C, and A is perpendicular to D, then B is perpendicular to D, and C is perpendicular to D. Right?
Like, I understand.
That is
That's so
exactly.
many words.
Yeah, that's exactly what I did the first time I read this. I was like, what? So I had to go back and I had to color it for myself, and I'll color it for you. If A is parallel to B and C, and A is perpendicular to D, all the green information is given, the student can deduce that A is perpendicular, that D is perpendicular to B, and D is perpendicular to C.
Okay, that's easy.
Right? So if I have a large set of parallel lines, and one line is perpendicular to one of those parallel lines, then it's perpendicular to all the other ones. Does that kind of make sense? So I think I wrote it
Sure.
something not as fantastic as that. If multiple lines are parallel, and one line is perpendicular, then it's also perpendicular to all the other parallel lines. It's not great, but I think it's better than what the book book says. So, kind of tying this back into our quiz on Friday. It says, can we prove that EF is perpendicular to CD? So right now they're telling us that AB and CD are parallel. They are also telling us that EF is perpendicular to AB. And we need to prove factually, without a doubt, that the green line and the red line are perpendicular. Does yes make sense? I need you to tell me in fantastical geometric terms that they are perpendicular.
Oh, okay.
Because the
Parallel, wouldn't see A, B, 90.
So you're right. You see this big 90-degree angle right here? So I have to prove that one of these four angles is 90 degrees.
Oh,
And can you justify that statement? That angle 2 is 90 degrees.
yeah. See better.
It makes sense, right? But do we know why that is possible?
Because AB is parallel to CD and AB is perpendicular to EF. So then that would mean that CD is perpendicular to EF too.
You're right. You're missing one huge piece of information. Corresponding angles. So, right, that's what you were saying. You just didn't say the word. So you see how the red and blue lines are parallel? So if this angle is 90 degrees, by the definition of corresponding angles, this angle has to be 90 degrees, period. Undoubtable. So now that this angle is 90 degrees, what can you say about the green line and the red line? They're perpendicular. So like I said, guys, blah, ew, gross, nasty, it doesn't make any sense. We're slowly picking it up. Alright, and here's where you said, right? Is it always true? So let's just call this dumb student. Let's call this dumb student Brad. Okay?
No, we have to name him Kyle.
No, his name's Brad.
We have to name him Kyle.
Brad, according to theorem 3-9, we're saying Brad because that's my name.
Oh,
Okay,
yeah,
let's
right.
make the connection. Brad is the teacher's name, so Brad's an idiot. That's me. Brad says that AB and BC must be parallel because they're both perpendicular to BF. So here's what Brad's saying. We have line BF
You really don't like Brad.
and AB and BC are both perpendicular to BF. So AB and BC must be parallel. But the student is wrong. Explain why Brad's an idiot.
Those are all the same line.
So if you look at the actual diagram, here is AB and here is BF. Are those perpendicular? Yeah, 90 degrees. Okay, here's BF and here's BC. Are those perpendicular? Yes. But why are AB and BC not parallel?
Because they're not the same. They're not touching each other all the same.
Because they're touching each other.
If we didn't have a diagram, could we assume that yes is true?
If there was no diagram, then it would be true.
Because it would.
But because there is a diagram, it's no longer true. And this is why it's not always true.
How does the diagram determine if it's true or false?
Because
Based on what you remember.
based on what I'm talking about, like Brad's like, well, Baker told me this, right? But here's the diagram. We actually have to apply information that's given in the problem. So if you look at these two lines right here, this green line and this green line, based on this information, are those two green lines parallel? And why doesn't it work? Because they're in different planes. So when they're all in the same plane, I can draw it like that, and it works every time, all the time. But when they're in different planes, it's not always going to work. Okay,
You just pray.
yes, this question has haunted me for years.
Okay.
And I always go through like, should I take it out or should I leave it in? Now tell me why this question sucks, please. It says the following statements describe a set of railroad tracks. How many of you guys know about railroad tracks? How much do you know about railroad tracks?
A decent amount.
To be determined, okay? Based only on the statement, make a conclusion about the rails and the railroad ties. Uh-oh. How much do you know about railroads? Significantly less hands go up for the YouTube viewers.
No, I just didn't.
What is a rail?
A rail is a metal part that the wheels roll on.
Okay, a rail, whoa, is what the train rides on.
The ties are the wooden things that lie perpendicular to the rails.
So a train rides on the rails. Now listen to this. Ties tie the rails together. Hence why they're called railroad ties, because they tie the rails together. They could be wooden, they could be metal. It depends. So that is now our railroad diagram. Is everybody okay with that?
Yeah.
So
Use some
based
more ties though.
only on this information, I'm not going to, you're going to see why here in a second.
So,
The railroad ties, that's these things right here, are each perpendicular to one rail. Would you like our railroad ties to be perpendicular to the top rail or the bottom rail?
oh,
Okay?
Doesn't matter.
Each of our railroad ties is perpendicular to the top rail.
Doesn't matter.
I'm asking you to make a justification about the rails or the ties.
so the ties are parallel to each other.
You're saying that the ties are parallel to each other. We can make that justification. Ties are parallel. Check. Happy Baker. Is there anything else that you can justify?
The rails are parallel to the
The rails are parallel. That's also not true.
Oh, I get why.
Okay, now, this is hard for us to understand. So because this tie and this tie are perpendicular to the same rail, they have congruent corresponding angles, so ipso facto, those two ties are parallel to each other. Undoubtable facts. Now, what if somebody made a rail look like this? So now I introduced the green rail.
Actually, they have.
Did I change any information from question 13 up here on the top? That is all still true. But what about the information on the bottom? That has changed. So it can either be the black scenario or the green scenario. So do the rails have to be parallel for this information to be true?
No.
So you cannot make any justification about the rails. Does that make sense?
Or
Where?
it's just two different questions.
It's two different questions.
Oh.
Okay, so in scenario number one, the only thing I can undoubtedly say is that the ties are parallel to each other. Okay, the other rail could be up or down, it doesn't matter. Let's try it again. The rails are parallel. You cannot dispute that. The rails are parallel. The railroad tie is perpendicular to one rail. Would you like the railroad tie to be perpendicular to the right rail or the left rail? Okay.
Right.
I know only that information. The rails are parallel and the railroad tie is perpendicular to the left rail. Is there anything else that I can justify?
Lines are rails are parallel.
Thank you for reading. Is there anything else that I can justify? You can and only justify this, that tie is perpendicular to the right rail.
Because all the other ties can be just
The other ties can look like this.
singular ties.
It could be an old broke down railroad. I can say nothing else about the other ties except the one tie that is perpendicular to the left, I know is perpendicular to the right.
So basically, there just can't be assumptions.
Right, it has to be factually based. Now, This is the one that everyone actually tries on and they actually enjoy it. Okay? So I'm gonna walk around and I'm gonna take a picture of your answer.
Oh, God.
I'm not gonna tell you whose answer right on the board. Hopefully we're all right, but hopefully we all do it a different way. I'm asking you to be a master city planner and design a neighborhood that has Apple Road, Blueberry Road, Cornflower Drive, Daffodil Lane, and Evergreen Road.
Can I use a ruler?
No, you don't really need to use a ruler. I'm
Rulers
gonna
don't
skip
exist.
past that. So I'm asking you guys to draw 5 roads: Apple, Blueberry, Cornflower, Daffodil, and Evergreen, or A, B, C, D, and E. And make sure that they meet the following requirements. I'm gonna walk by and just take a small picture of 3 people. I'm gonna draw your answer on the board, and we're gonna see if we have the same answers, if you have the different answers. At the end of the day, I'm only asking you to do this. What is the relationship between Apple and Evergreen? So your answer is Apple is parallel to Evergreen, or Apple is perpendicular to Evergreen based on your master city planning.
Can we just write that as the answer?
That is all you have to write, but you might need to draw the roads to make sure you do it correctly. So just sketch them. Doesn't have to be perfect. Just sketch parallel, perpendicular, perpendicular, parallel, parallel, perpendicular, however it works out, and give me an answer. If you want me to take a photo of your answer, let me know. I'll snap a photo of it, and then I'll draw it on the board. But I will not tell whose picture I'm drawing.
You're supposed to tell me these things.
Need one more photo. Alright, I'm going to draw these in no specific order, but feel free to keep working. What do we got?
Use my photo.
Yeah, giddy.
Alright, those are the 3 answers that were randomly selected. Now, does your picture look different from that?
Yeah.
100%.
But this person says that Apple and Evergreen are
L.
parallel. This person says Apple and Evergreen are parallel. This person says that Apple and Evergreen are parallel. So we have 3 parallels up there. Now, when I did it, because I'm super fancy, I said
I feel like I did it wrong.
Apple is perpendicular
Perpendicular.
to blueberry.
I just do my.
Blueberry is parallel to cornflower. And then cornflower is perpendicular to daffodil. And then evergreen, or daffodil and evergreen are parallel. So with the colors, it's a little easier to see because what do you know about red and green? Parallel. Alright, so class quiz here real quick. There's no hiding now. We got like 3, 5, 4, and 4. You guys are number 16. I need you to answer A is blank to D. You guys are number 17. You guys are number 18. You guys are number 19. All you have to do is say A is blank to D, and it's either parallel or perpendicular based on the statement that you've been given. So y'all are 16, 17, 18, and 19. These are 25 points apiece. The class will score as a class, and pass as a class, or fail as a class. When you have an elected speaker, let me know, and I will write your answer on the board.
Ha, you're funny.
It would probably be a good idea to draw that. I don't know, just saying.
You gave us an easy one, because there's 3 of us.
Did I?
Yeah.
Did I give you a harder one?
No, I like this. I have to go with my answer.
You want to write it?
Oh yeah, right up
Are you going to draw it too, or are you just going to write it? Okay. Alright, so -1 so far.
No points for not
Why you
knowing?
lying?
Number 16. A is parallel to B. B is parallel to C. C is parallel to D. What do you know about A and D?
They're parallel.
No. What you got? You want to write it or just tell me? 17 is perpendicular. Let's check it. A and B are parallel. B and C are parallel. C and D are perpendicular. So what do you know about A and D? They're perpendicular. Nailed it. 2 for 2. Perpendicular. Okay. A and B are parallel. C and D are perpendicular. C and D are parallel. So
Exactly.
perpendicular. Alright, we're at 75 right now. Can we get to 100?
Use the last
That's all.
Perpendicular. A and B. B and C. C and D.
Is this actually going into the grade?
Sure, why not?
Yeah, let's make it a test grade.
Oh, okay. So I want to be very truthful about where this is going, right? At this point in your learning process, you're like, it seems easy, doesn't it? But so why would we do this? The whole goal today is: do you know parallel, and do you know
Perpendicular.
perpendicular? So I'm going to ask you to regurgitate that knowledge on those 6 questions. Those are the only 6 I'm asking you to do on your homework. 1, 2, 4, 5, 6, and 9. 1, 2, 4, 5, 6, 9. Now, let me tell you where this is going.
Oh, because we did all I just grabbed the note on.
This is where it's going. Are A
Whoa.
and B
Blank.
parallel or perpendicular?
Perpendicular.
Wait,
Are they
what?
though? Because we check now.
How are we about to check this? Aaron, what do you need to solidify a correct or incorrect answer? Algebra, that's calling the slope of the line.
Oh, we're
Y
doing this again?
equals negative x,
Oh, and they have to be Y on opposite.
or y equals 2/3 x plus 2.
I thought you said the word algebra wasn't on this.
So this is me asking for you guys to verify geometry concepts algebraically. Guys, I cannot stress enough. We're about to throw you guys into a world where you have to say parallel or perpendicular based on slopes of lines.
I hate slopes.
And guess what? Get over it. Because you have to look, and this is the easy scenario. I give you two equations. And you say the slope of this one is this, the slope of this one is that. And I can say parallel, perpendicular, or neither. And then I will ask you to, here is a line. Please write your own equation for a line that is parallel to that and a line that is perpendicular to that. So then you have to know what the slope of that line is, find it algebraically, then you have to create your own parallel and perpendicular slope. So, guys, this is where it's going, right? We're talking about parallel perpendicular.